Hi, hello dear students. Welcome to physics class of YouTube. We have been discussing here an important chapter, that is the dual nature of radiation and matter. So in the previous classes we have discussed about the introduction part of the chapter. Already we have discussed, that is what are the different types of electron emission and what is the phenomenon of photoelectric effect, right? And what are the important experimental results of the photoelectric effect, experimental study, experimental arrangement we have studied, and also what are the important experimental results of photoelectric effect, and what is the Planck's quantum theory of radiation. The important part of this is the Planck's quantum theory of radiation. Based on the Planck's quantum theory of radiation, Einstein given the photoelectric equation. So based on Planck's quantum theory, Einstein given the photoelectric equation. Based on that photoelectric equation, he given the explanation for the experimental results of the photoelectric effect. The important results of the photoelectric effect, experimental results of photoelectric effect, what we have discussed in the previous classes. It is an instantaneous process. Threshold frequency is required. Then the kinetic energy of the emitted photoelectrons is directly proportional to the frequency of incident radiation. Then the photoelectric current is directly proportional to intensity of incident radiation. So the Einstein given the explanation for these results based on his Einstein photoelectric equation. That is called as what? The Einstein photoelectric equation. So according to the Einstein, the photoelectric effect, the phenomenon of photoelectric effect is due to what? It is due to what? An elastic collision between the photon and the electron. When a photon of energy E is equal to h nu is incident on the metal surface, there is due to what is meant by elastic collision. Elastic collision means there is no loss of energy. The energy of the photon is transferred to the what? The electron. Right? So during the collision, what happens here? The free electrons exist inside the metal, and that electron absorbs the energy from the photon, and that gained energy is equal to what? E is equal to h nu. If E is equal to h nu is the energy of the photon, then that energy is transferred to the electron present, free electron present inside the metal. Right? And if this energy is equal to h nu, this energy is greater than the work function of the metal. You know, minimum amount of energy is required to liberate the electrons from the metal surface. That is called as what? The work function. The incident energy of the photon must be what? Greater than the work function energy. Then only what happens here? The electron will liberate it from the or ejected from the metal surface. And if the energy of the incident photon is greater than the work function, then excess energy will be what? The kinetic energy of the emitted electrons. So if E is equal to h nu, it is what? The energy of the incident photon. This amount of energy photon adittanದ್ರೆ electron minimum amount of energy ಬೇಕಾಗ್ತದೆ. That is called as the work function. It is denoted by the symbol pi naught. So work function of the metal is what? Pi naught. Then E is equal to h nu is the energy of the incident photon. Out of this, according to Einstein, the energy of the photon, it is used for two purposes. One is for the work function of the metal. Right? First one, it is for what? The work function of the metal. Work function of the metal means what? The electron will just comes out of the surface. Right? Just for work function of the metal, the electron comes out of the surface. It will not completely come out of the metal. Right? To come out of the metal, the electron should have some kinetic energy. Right? It will escape from the what? Surface for this work function. Then after that, if the energy of the incident photon is greater than the work function of the metal, then excess energy will be kinetic energy of the electron. Then if v is the velocity of the electron that is ejected by taking an extra energy greater than the work function, then the kinetic energy of the electron will be what? Half m v square, where Vmax is what? The maximum velocity of the ejected electron by taking an extra energy greater than the work function. So the total, according to Einstein here, the total energy of the incident photon, it will be used for the two purposes. One is for the work function and another one is what? The kinetic energy of the ejected electron. That is called as what? The Einstein photoelectric equation. Now let us write here the Einstein photoelectric equation. Let us write here what? The Einstein photoelectric equation. Then we will explain the experimental results of the photoelectric effect based on his photoelectric equation. So the Einstein photoelectric equation is written as what? The energy of incident photon. The energy of incident photon is equal to what? Work function. Work function plus what? The kinetic energy of the ejected electron. That is what? Kinetic energy of photoelectrons. So according to law of conservation of energy, this equation should be satisfied. The total energy of the incident photon must be equal to the work function plus kinetic energy of the ejected electrons, or maximum kinetic energy of the emitted photoelectrons. So in this way we are going to write here in the symbolic form. What we can write here, E is equal to work function is pi naught and the kinetic energy is denoted as what? Kinetic energy, the maximum kinetic energy of the emitted electrons. So here the energy of the incident photon E is equal to what? H nu, and this is equal to what? H nu is equal to pi naught, that is the minimum frequency of incident radiation is required. So that is what? H nu naught. So here nu naught is what? The threshold frequency. Then if v is the velocity of the photoelectrons, then kinetic energy is given by half m v square. Right? So what we can write here then? Kinetic energy of the ejected electrons is equal to Ke is equal to what then? H nu minus H nu naught, or by taking H as a common, nu minus nu naught. So this is equal to what? The kinetic energy of the ejected electrons or photoelectrons. Now let us explain here one by one the experimental results of the photoelectric effect. The 5 experimental results what we have discussed. Let us discuss here the explanation for the experimental results of the photoelectric effect based on this photoelectric equation. So this is the kinetic energy. It is H into bracket nu minus nu naught, where nu is the frequency of incident radiation, nu naught is what? The threshold frequency, right? Nu is frequency of incident radiation, and nu naught is threshold frequency. Nu naught is what? Threshold frequency, right? So here we have based on this photoelectric equation, let us explain here the experimental results of the photoelectric effect based on this equation, based on this photoelectric equation. Right now, the first result. Let us explain here. The first experimental result of the photoelectric effect is what? The photoelectric effect is instantaneous process. The photoelectric effect is what? Instantaneous process. Why it is instantaneous process? What is the reason for instantaneous process? The explanation for the instantaneous process based on the Einstein photoelectric equation is what? So as I already told you, it is an elastic collision between, it is what? The elastic collision between the photon and the free electrons present inside the metal. Right? If it is elastic collision means there is a no loss of energy in the collision. The energy is transferred from what? From the energy is gained from the photon by the electron. And there is a no delay in the, or there is no lagging process in the what? The transfer of energy or gain of energy. So that's why it is what? The instantaneous process, because of what? The photoelectric effect, it is what? The collision between, elastic collision between, it is elastic collision between photon and electron. So it is an elastic collision between the photon and the electron, and during that collision what happens here? During the collision, the energy of the photon is transferred to the electron without the time delay. Without delay in the time, there is a transfer of energy takes place from photon to the electron. So that's why that electron takes the energy immediately, and then if the energy of the incident photon is greater than the work function, then that electron will be emitted as a photoelectron. Right? Then hence you will get the photoelectric current. So the simple explanation for the instantaneous process is, it is the elastic collision between the photon and the electron. Without delay in the time, the transfer of energy takes place from photon to the electron. So that's why it is instantaneous process or immediate process. Now second one, threshold frequency. The explanation for the threshold frequency. What is threshold frequency? The minimum frequency of the incident radiation for which the photoelectric emission takes place. The minimum frequency of the incident radiation is required. For that frequency only what? The photoelectric emission takes place, or photoelectrons are emitted. So what is the threshold frequency? We have denoted here mu naught. Right? Mu naught. So as we have written here, the kinetic energy of is equal to what? H into mu minus mu naught. Right? If the frequency is less than, here mu is what? Here mu is what? The frequency of the incident radiation. If the frequency of incident radiation is less than the threshold frequency, then you will get the kinetic energy is negative. So that time what happens? That time mu is less than mu naught. So we have the bracket here, right? A minus B. If A is less than B, then you will get negative term. Right? If A is less than B, then you will get negative term. So that's why the total kinetic energy becomes negative. The total kinetic energy becomes negative. So mu is the frequency of incident radiation. mu naught is threshold frequency. If the frequency of incident radiation is less than the threshold frequency, then kinetic energy will be negative. So the kinetic energy is negative means what? The kinetic energy negative means what? The negative kinetic energy means what? There is no photoelectric emission. This implies what? This implies no photoelectric emission. So for positive kinetic energy only what? The photoelectric emission is possible. The electron will be ejected from the metal surface with velocity v. No photoelectric emission. So this is what the threshold frequency, the explanation for why the threshold frequency is required for photoelectric emission. Nu must be what? Nu must be greater than mu naught. And if mu is equal to mu naught, that case what happens? Mu is equal to mu naught, then kinetic energy is equal to 0. If mu is equal to mu naught, then kinetic energy is equal to 0. That kinetic energy is equal to 0 means what? That we have supplied the only energy is equal to the work function. The only energy is equal to what? The work function. Then kinetic energy becomes 0. If the kinetic energy is equal to 0 means what? If the kinetic energy is equal to 0 means what? The electron doesn't have any energy to move with the velocity, its velocity is equal to 0. That means what? The next explanation, what we are going to explain here, right? The kinetic energy of the photoelectrons the kinetic energy of the photoelectrons is directly proportional to the what? The frequency of incident radiation. The kinetic energy of the photoelectrons is directly proportional to what? Frequency of incident radiation. So what does it mean? The kinetic energy of the photoelectrons is directly proportional to the frequency of incident radiation. So again you can refer this equation here. The kinetic energy is equal to h into nu minus mu naught, right? So kinetic energy increases as this term is constant, mu naught is constant. As this mu value goes on increases, the kinetic energy of the photoelectrons also goes on increases, right? So that is what, as you know, that is energy is directly proportional to frequency of incident radiation. As the frequency of incident radiation increases, the energy of the incident photon increases. But only the electron will take the work function of the metal, and the remaining part of the energy will becomes what? The kinetic energy of the electrons. So the total energy of the photon ಏನಾಗ್ತೈತ್ರಿ ಅದರೊಳಗೆ ವರ್ಕ್ ಫಂಕ್ಷನ್ ದಷ್ಟು ಎನರ್ಜಿ ಏನಾಗ್ತೈತ್ರಿ that it is used to come out of the metal surface from the up to the surface, right? Then after that, to move with velocity v, there should be a positive kinetic energy, right? When the frequency of incident radiation is greater than nu naught, then what happens here? Kinetic energy is equal to as nu is greater than nu naught, this term becomes positive. So h is equal to nu minus nu naught. Kinetic energy is equal to what? H into nu minus nu naught, and nu is greater than nu naught, then kinetic energy will be positive. As the frequency of incident radiation is greater than the threshold frequency, then kinetic energy becomes positive. Then electron is move with velocity v by taking an extra kinetic energy. So photoelectric emission is possible. Photoelectric effect is possible. Photoelectric emission is possible for mu is greater than mu naught. For the frequency of incident radiation greater than the threshold frequency, the kinetic energy of the photoelectrons becomes positive. Therefore, there is a photoelectric effect takes place. And when this nu is increases, the frequency of incident radiation increases, the kinetic the energy of the photon also goes on increases, then the kinetic energy of the electron also goes on increases. Only the work function of the metal becomes constant, so that is constant. But as nu increases, the energy also increases. Finally, the kinetic energy of the photoelectrons also goes on increases with increase in the frequency of incident radiation. So that's why all the results of the photoelectric effect are explained based on the Einstein photoelectric equation. First one, instantaneous process, because of what? The elastic quality between photon and electron. Threshold frequency is required because of what? If the incident frequency is less than nu naught, then kinetic energy is negative, so no photoelectric emission for negative kinetic energy, right? If nu is equal to nu naught, then kinetic energy is also equal to 0, so therefore there is no photoelectric current. So we don't have the electrons with velocity v. Then the kinetic energy is directly proportional to frequency of incident radiation. Because of what? Kinetic energy is equal to h into nu minus mu naught. So as we have discussed in the result, as the frequency of incident radiation increases, its kinetic energy is also increases. So as the nu is greater than mu naught, we have positive term here. As nu increases, again more and more positive you get here. So that's why the kinetic energy of the photoelectrons increases with increasing the frequency of incident radiation. And one more result that we are going to explain here, that is the photoelectric current. Photoelectric current or photocurrent is directly proportional to intensity of incident radiation. So what is the reason for this? intensity of incident radiation. So as we have discussed in the properties or characteristics of the photon, more the intensity, more the number of photons. Intensity of light ಜಾಸ್ತಿ ಇದ್ದರೆ number of photons that incident on the metal surface per second also increases. Number of photons increase ಜಾಸ್ತಿ ಆಗಿದೆ. As the number of photons increases, that means what? The more number of free electrons will take that energy. So the electron number also increases. The free electron number also, the electrons also increases. Right? As the number of photons incident on the metal surface increases, that increases what? That means what? The more number of free electrons inside the metal take that photons and they are ejected. So as the more number of electrons, photoelectrons are coming out of the metal surface, that indicates what? The photoelectric current also increases. So the photoelectric current increases because of this, with increasing the intensity of radiation. More the intensity, more the number of photons emitted, so more the photoelectrons are coming, so more is the photoelectric current, because the photocurrent is depends upon what? The number of electrons, the flow of charge. That is what the photoelectric current. So this is what the important explanation regarding experimental results of the photoelectric effect. So in the examination you will get the 5-mark question. Write Einstein photoelectric equation. Write Einstein photoelectric equation and explain the terms involved in it. Explain the experimental results of the photoelectric effect based on Einstein photoelectric equation. So 4 plus 1 mark. So here you have to write these 4 results and you have to write this equation and explain the terms. And in the next class we will discuss some numericals or some other next part of this syllabus. Okay, thank you so much.
Leonard observation on the photoelectric effect. What a scientist Leonard observed the photoelectric effect based on his observations. What he given the conclusions on his suggestions or on his observation. Right. So this is an experimental arrangement as we have studied in the previous class. There is an evacuated glass tube. It is fitted with a side window, quartz window, so through which the electromagnetic radiations are illuminated on the emitter plate. So this is known as what? The emitter plate. And this is anode. The emitter plate acts as the cathode and it is anode, which is also called as the collector plate, which collects the electrons. And these anode and cathode, this cathode and anode are connected to a battery through a key and a microammeter to note down the current. Now, what is the Leonard observation on photoelectric effect? So, in an electromagnetic radiations, right, what is chosen as a UV radiations? What is the observation made by him? It is what? When an ultraviolet radiations, when UV radiations are allowed to fall on the emitter plate, right, a current flows in the external circuit. He used ultraviolet radiations. That is the Leonard observation. He used only an ultraviolet radiations were allowed to fall on the emitter plate in an evacuated glass tube, which is enclosed with what? The two cathode and anode. This is an emitter plate and this is what? The collector plate. And a current flows in the external circuit as soon as the radiation falling on the emitter plate, and when the radiation falling stops and the current also stops. So this is the observation observed by what Lenard based on what the photoelectric effect by using UV radiations. So what he observed, as soon as the UV radiation is incident on the emitter plate, when UV radiations are incident on the emitter plate, a current flows in the external circuit. Current flow ಆಗ್ತೈತೆ ಎಲ್ಲಿ ತನಕ UV radiations fall ಆಗ್ತಿರ್ತವೆ ಅಲ್ಲಿ up to that case what happens, the current flows in the circuit. But what happens, the current flow stops. The current flow stops when the UV radiations are stopped. So ಯಾವಾಗ ನಾವು UV radiation ಇನ್ಸಿಡೆಂಟ್ ಆಗೋದು ಅಥವಾ ಇಲ್ಯುಮಿನೇಟ್ ಆಗೋದು ಒಂದು ಎಮಿಟರ್ ಪ್ಲೇಟ್ ಮೇಲೆ ಸ್ಟಾಪ್ ಮಾಡ್ತೀವಿ, ಅವಾಗ ಏನಾಗ್ತದೆ, ದ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಆಲ್ಸೋ ಸ್ಟಾಪ್ಸ್. ಸೊ ವಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಫಾರ್ ದಿಸ್ ದೆನ್? ದಟ್ ಈಸ್ ಡ್ಯೂ ಟು ವಾಟ್? ದ photoelectric effect. When ultraviolet radiations fall on the emitter plate, when ultraviolet radiations fall on the emitter plate, electrons are emitted. Electrons are emitted, and these electrons are attracted towards what? The end. These electrons are attracted towards what? The collector plate. Hence the flow, because of these electrons, flow of electrons in the external circuit, that results in the what? The current to the external circuit. So UV radiations falls on the emitter plate, the electrons are emitted, they are moved towards what? The collector plate. Hence you will get what? The current in the external circuit. But when UV radiations are stopped, there is no current in the external circuit. So this is what the Lenard observations on the photoelectric effect used by using what? The UV radiations. So this is what mainly due to the what? The photoelectric effect here. The process of emission of electrons when a light of suitable frequency incident on it. That is known as the threshold frequency. So this is what the Lenard observation on photoelectric effect. Now there is one more scientist, Halbach, made an observation on photoelectric effect. Now let us discuss about the Halbach observation on the photoelectric effect. So as we have discussed about the Lenard observation on photoelectric effect, now what is the Halbach's observation on the photoelectric effect here? So here the cathode or the emitter plate, which one used by the Halbach is zinc plate, right? What is the observation made by the Halbach here? He used the zinc plate as an emitter plate. Zinc plate use ಮಾಡ್ತಾನೆ. Then what happens when an UV radiations are illuminated on the zinc plate? What happens to the external circuit or through the current, or what happens to this zinc plate? Right? When an UV radiation is illuminated on what? The zinc plate, because of the photoelectric effect, what happens? These electrons are attracted towards the collector plate and you will get the current to the external circuit. But what happens? What he observed, due to the emission of electrons, what happens? The uncharged zinc plate becomes the positive. Electrons remove agakatavandre enagbekrri, it becomes, the material becomes positive. The electrons are removed. Neutral means what? Uncharged means number of positive charge is equal to negative charge. That is called as neutral. ಮೊದಲು ಏನಿತ್ರಿ ಜಿಂಕ್ ಪ್ಲೇಟ್ ನ್ಯೂಟ್ರಲ್ ಇತ್ತು, right? But when UV radiations are incident on it, the electrons, you will get the electrons are removed from the zinc plate, so that what he observed, the zinc plate becomes positive when it was illuminated by UV radiation. So photoelectric effect ಆಗ್ತಾ ಇದೆ ಇಲ್ಲ ಅನ್ನೋದನ್ನ ಯಾವ ರೀತಿ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಬೋದಂದ್ರೆ ಅವ, ಬಿಕಾಸ್ ಅನ್ಚಾರ್ಜ್ಡ್ ಜಿಂಕ್ ಪ್ಲೇಟ್ ಇದ್ದಿದ್ದ ಪಾಸಿಟಿವ್ ಆಗಾಕತ್ತೈತಿ, ರೈಟ್? ಪಾಸಿಟಿವ್ ಮೀನ್ಸ್ ವಾಟ್? ದ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಮೂವ್ ಆಗತ್ತವ್ರಿ. So when the number of electrons are removed, it becomes more and more positive. So what he observed, then positively charged zinc plate becomes more positive again when it is illuminated by UV radiation, right? Model neutral idre, when UV radiations are illuminated on it, the zinc plate becomes neutral, zinc plate becomes positively charged zinc plate. So what happens in this way? The photoelectric effect takes place here. ಈ ರೀತಿ ನಾವು ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊತೀವಿ. ಯಾವ ರೀತಿ? ನ್ಯೂಟ್ರಲ್ ಇದ್ದಿದ್ದ ಪಾಸಿಟಿವ್ ಆಯ್ತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಮೂವ್ ಆಗತ್ತವು ವೆನ್ ದ UV radiations are incident on it. So this is what the Halbach observation on the photoelectric effect. So in these are the two Lenard and observations on photoelectric effect. So this is a very very important point. So in the exam they may ask for 3 mark question, right? Halbach and Lenard observation on photoelectric effect. It is very important question for 3 marks in dual nature of radiation and matter, right? So I think you have got what is Lennard observation and what is Hallwach observation. Hallwach observation again nodri, uncharged zinc plate the positive akriti, it becomes positively charged zinc plate. Why it becomes positively charged? The electrons are removed from that plate here by illuminating UV radiation. So in this way he confirmed what? The photoelectric effect, right? So this is about what? Hallwach observation on the photoelectric effect. So what is the conclusion you can make from the Hallwach observation on photoelectric effect here? That is what? When an UV radiation are fall on the zinc plate, it loses more number of electrons and hence it becomes what? Positively charged. So that what is the conclusion we can give here? The negatively charged particles are ejected out of the zinc plate, so under the action of UV rays. So this is what the Hallwach observation on the photoelectric effect. So this is the very important point on what? The Hallwach observation. ಇಲ್ಲಿ negatively charged particles emit ಆಗಿರೋದ್ರಿಂದ negatively charged particles, that is electrons, are emitted, so that this zinc plate becomes what? This zinc plate becomes what? Positively charged.